So the title of the fifth unit is control mechanisms. There are two subdivisions in the fifth unit. Okay, the first half of the fifth unit deals about governors. Okay, so we are going to see what are governors and everything. The second half of the fifth unit deals with gyroscopic effect and gyroscope usage of gyroscopes in various applications. So last time in the dynamics lab we have seen that gyroscope experiment, how gyroscopic couple is generated. So all those things we explained. Once again, we will give a brief explanation about the gyroscopic effect in the second half of this unit. But the first half is governors. Okay. So introduction to governors. The function of a governor is to regulate the mean speed of an engine when there are no variations in load. Example, when the load of an engine increases, when there is a variation in load, sorry, not no variation, when there is a variation in load, when the load of an engine increases, its speed decreases, therefore it becomes necessary to increase the supply of the working fluid. So what is the working fluid in this case for an engine? Your petrol or the diesel, whichever is going to give you the combustion energy. Your working fluid is your fuel in case of an engine. In case of a hydraulic turbine, working fluid is water. Okay, in case of a steam turbine, working fluid is steam. So like the governors are used everywhere. Okay, so you are going to control the working fluid in response to the mean speed of the engine. Okay, so how do you do that? We are looking at, see, all of you have done thermal lab. So what happens when you do a load test on an engine? When I add the, so when there is no load condition, let us say the engine is running at 700 rpm. When I add a 1 kg load, it drops to 680 or 670. You keep adding loads, the rpm comes down naturally, correct? When you increase the load, there is a drop in the rpm of the engine because you are increasing the load so that the engine has to do more work to gain the same speed. So what is the function of a governor? See, when with keeping your throttle constant, when you are riding a bike, if your throttle is at a constant speed, right? So when you suddenly add some load to the engine and you with the constant position of the load, throttle means that your engine should be running at some 2000 rpm. I am suddenly adding some weight to that without any change in the throttle valve position. So the governor senses that there is a drop in the engine speed without any change in the fuel supply, the throttle valve position. So the governor senses that you need to send in more fuel to increase the speed to match with the required velocity at that given throttle position. So the governor does it. It alters the fuel supply, working fluid quantity that is going into the engine and the combustion taking place, the amount of energy that is coming out when your throttle position is constant, right? You should not say that when I change the throttle, what will happen? Governor functions per constant speed. At a given speed, the function of a governor is to maintain the speed. If you deliberately change the throttle position, then governor will not do anything. It will again at the new velocity it will start functioning. Okay. when the load on the engine decreases, its speed increases. This is obvious, right? When you start removing the load, slowly its speed increases so that I have to control the increase in speed and bring it to some economical value. Governor automatically controls the supply of the working fluid to the engine with a varying load condition, keeps the mean speed of the engine within certain limits, right? So I have given you a small animation of how does a governor function. So the governor is driven, if you see here, you just have a close look at my mouse pointer, because if I start writing on the screen, the GIF will stop. So this shaft is coming from your engine crankshaft. It is beveled to a governor. So this portion is your governor. Okay. The governor has two masses that are going around, right? So when the speed of the engine increases, the speed of rotation of the governor, this spindle increases. Obviously, what will happen? The two balls that are connected to this central shaft via some links will start rotating faster. So the centrifugal force of these masses will pull the balls outward. That centrifugal force is going to pull your sleeve upwards. Okay, so this sleeve is going to be linked to your throttle valves through some linkages. So that controls your change in speed, right? This depiction, this whole demonstration is exaggerated so that you can understand what is happening. But actually, the change in position is very minute. Not more than 1 degree of oscillation is going to occur when throttle valve is constant. So that particular RPM of the engine is maintained with the help of a governor, and this swinging of this link is very minute. Okay, it happens very minutely. This is shown in an exaggerated pattern so that you easily understand what is happening. A little consideration will show that when the load increases, the configuration of the governor changes and the valve is moved to increase the supply of the working fluid. Conversely, when the load decreases, the engine speed increases and the governor decreases the supply of the working fluid. Right? Whatever was told earlier. When your engine is going beyond the required speed, governor will control it and reduce the speed. When your engine speed is going below the required speed, it will increase the working fluid supply and control the engine speed so that it maintains the mean speed. So that is a function of a governor. Okay. Types of governors, broadly classified as centrifugal governors and inertia governors. Okay. So further, centrifugal governors may be classified as shown below. Centrifugal governors, we have two types. So pendulum type governor, we have only one governor, watt governor. It solely depends on the two balls that are rotating. Okay. So this is very inaccurate. It was the first initial governor. Watt governor was the first type of governor invented. So from this only all the other designs came. Okay. So watt governor is the primitive type of governor. From that all the other designs started. So it's a pendulum type. Loaded type. So loaded type I have dead weight governors and spring control governors. Dead weight is Porter, Proel. Okay. So these are the names of the governors. Different types of governors invented by these people. Porter, Proel. Spring control governors you have Hartnell, Hartung, Wilson Hartnell, Pickering. So what are all the things we are going to study in our syllabus? So we are going to study watt governor. Watt governor is the simplest governor. We are going to do only one problem on that. It's very simple. I'll leave it to you. We'll do one simple problem and then the rest is left to you. It is not really important from exam point of view. So then we are going to do Porter governor, Proel governor, and Hartnell governor. So all these governors we are going to do some derivations and derive the formula required to find out the velocity and the height of the governor, all those things. Okay. So these things you have to theoretically have a look. You have to understand what are all these governors, and maybe out of uncertainty there is a possibility that you may get one problem from Hartnell, but it is very uncertain. So we may not have time to do this. So I'm going to stop here. We are going to do four types: Watt, Porter, Proel, Hartnell. If you study all these four, certainly you can attend your question 15A. 100% you can attend it. Okay. So centrifugal governors, so they solely depend on the masses and their centrifugal force acting on the masses. Okay. So these balls are known as governor balls or fly balls. The balls revolve with a spindle which is driven by the engine through bevel gears. Right. The schematic representation is shown. This is what was shown as a image. So now this bell crank lever which you saw earlier is going to control your throttle valve position very minutely. It will not open like this. Okay. So very minute adjustments when the throttle is constant due to change in the terrain. Let us say you are going on a flat road, suddenly you take our college for example. When you are crossing the Tachur junction, what happens? Your bus starts to climb a bridge. Gradually your bus slows down. The driver shifts the gear down. He comes to first gear. Why does it slow down? Obviously when you are going to climb uphill, when you are going to climb a road, not exactly flat, you are going against gravity. So you need to do more work. In such cases the governor will step in and do some adjustments, but when your terrain is very high, it is not enough. You have to come down the gears and adjust the torque requirement and all those things. You are going to do that in next semester automobile engineering. So as of now, you understand due to the terrain of the road or due to some other requirement or maybe some change in the load conditions of the vehicle, the minute response is given by the governor without the hindrance of the driver. Upper end of the arms are pivoted to the spindle so that the balls may rise or fall down as they revolve the vertical axis. So I will go through these things a little bit faster because you can have a read. It's available in the books. Arms are connected to the links of sleeve. It may be connected in three different ways. So in order to limit the travel of the sleeve in upward directions, two stops are provided to the spindle. The sleeve is connected to the bell crank lever. So this is what I already told you. Same points are repeated again. So when you are going to study about a governor, you have to understand what are all these things. Height of the governor. What do I mean when I tell height of a governor? It is a vertical distance from the center of the ball to a point where the axis of the arms are intersecting at the spindle axis. Okay. Example. So whatever the governor you have seen in the last slide. So this is your ball. So from the center of the ball, so one link, the second link, they are intersecting at the spindle axis. They intersect here. So this is your height of the governor. Do you understand? So when I increase the speed of the governor, what will happen? The balls will start traveling outwards and upwards. Therefore, your height will reduce. Do you understand? What will happen if your governor is doing very fast? Your balls will fly outwards, still outwards, correct? So therefore, your height will reduce if your RPM is going to increase. Height will increase if your RPM is, because the simple, very simple logic. Balls will come down when you are slow. Balls will go up when you are fast. So when you go up, your height will decrease. When you go down, your height will increase. Clear? That is the height of a governor. Equilibrium speed. It's the speed at which the governor, balls, arms, etc. are in complete equilibrium and the sleeve does not tend to move upward or downward. It's very logical. When there is some change in equilibrium conditions, it takes a few seconds for the governor to stabilize and maintain the equilibrium speed. So that is your equilibrium speed. Okay. Mean equilibrium speed, speed at which the mean position of the balls are the sleeve. They are almost similar. Okay. So maximum and minimum equilibrium speed, the speed at the maximum and minimum radius of rotation of the ball without tending to move either way or maximum and minimum. So there is a maximum limit up to which these balls can fly outwards, beyond which the length of the links will limit your balls to travel outwards. Now that is your maximum equilibrium speed. Similarly, minimum. It can come down only up to some position beyond which the length of your link will stop the ball from moving downwards. That is your minimum speed. Okay. Sleeve lift. Vertical distance which the sleeve travels due to change in equilibrium speed. You have seen in the first slide animation, you have seen the sleeve is lifting and pulling the belt crank lever. How much height you are lifting? Change in height is sleeve lift. H1 minus H2. Okay? Very simple. So these things are taken from a Pumi textbook 18.1 to 18.4 sections.